Hello, this is AMET 104 lecture recording week 5.2. So in the last class, we went over retirement savings account. So let's do some recap. Retirement savings account. And here we actually looked at two different formulas. It's actually one formula, but it's modified to fit the other. So the first thing, so the formula is given as V equals to P multiplied by 1 plus R to the power of Y minus 1 and divide all that by R. So here, V stands for value, so it's a total value. Of the account. And P is the yearly investment. Let's say annual contribution. I think that's a better term. Annual contribution. And here, Y is the number of years. Contributed. And lastly, R is APR in decimal. So basically, if you are contributing X amount of fixed dollars into your retirement savings account, and let's say each year, so this is annual contribution, so you're investing P amount of money each year, and given X amount of years with an APR, this is how you simply find the total value by the time you actually retire and take out this the sum of money. So last time we also looked at another version of this. So this is the annual version. And there's a monthly version. Meaning that instead of making annual contribution, you now have monthly contribution. And that is given as such. So V equals to capital M multiplied by 1 plus R divided by 12, exponential by t minus 1, and you divide everything by R over 12. So these two are actually the same formula, but each variables are just defined differently. So here, obviously, the V is the total value. Of the account. And in this case, the M is the monthly contribution. And here T, excuse me. So T is the total number of months contributed. And lastly, R here also, APR in decimal. So this would actually imply that R over 12 is the monthly interest. So I know we looked at one example with several different scenarios and try to see that what actually yields greater total value at the end. So today we're mainly going to look at different examples, and there are only a few examples that I want to go over today. So hopefully today's class will be a little shorter. So let's look at an example. So find the value of the retirement savings account paying an APR of 5.9% after 45 years. And here, when making contributions, it's assumed that contributions are made at the end of each year. So just to keep everything uniform. So contributions made at the end of each year. What if the annual contribution, let's say the annual contribution is, let's say, $1,200. So knowing that the annual contribution is $1,200, and we also know that the length of the investment and the APR, we actually have all the information that we need to proceed to calculate this problem. So I'm going to rewrite the formula right here. V equals to P multiplied by 1 plus R to the power of Y minus 1 divided by R. So here in this problem, we can see that the P is given as $1,200. R, which is APR in decimal, should be 0.059. And the total number of years is 45 years. So by, excuse me, so by simply plugging in everything that we know, we should be able to get $1,200 multiplied by 1 plus 0.059. So in this case, I'm just going to simply write 0.059. And we do it for 45 years, and you divide by the APR. So if you put this into the calculator properly, you should end up with $247,977 and 55 cents. So that's a significant amount of money that you yield just by simply saving $1,200 each year. Okay, so let's look at another example, but in this case, let's keep the scenario the same. So we still have the APR of 5.9%, and we're investing for 45 years. The only thing we're going to change is the annual contribution amount. So this is part B, and let's say in this case the annual contribution amount is $740. It's a smaller amount. So when the annual contribution is $740, the only thing that we have to change from here is just the P. So in this case, we know that the P is 740, but the APR and the number of years contribution is the same as before. Then the total value will be 740 multiplied by 1.59 to the power of 45 minus 1, and you divide all that by 0.059. So after putting this in the calculator, we should be able to get $152,919.49. Let's look at one more scenario. How about if you invest $2,400 each year? So you can see that comparing to the scenario A, which in this case was the $1,200, it's exactly the double. And let's see how the final value turns out. So we're just trying to see the correlation between the annual contribution amount and the total value of the account. So in this case, we know that the P is now 2,400 and the APR is 0.059, and lastly, the number of years is 45. By simply plugging in, we're only changing this value and everything else actually stays the same. 59 to the power of 45 minus 1, 0.059. By putting this in the calculator, you should be able to get 495,955 and 11 cents. So let's actually compare this scenario A and C. Can we see that the contribution amount is doubled? So from $1,200 to $2,400 is exactly the double. Now let's look at the contribution amount. I mean the total value of the account. So the value here is 247,997, and in this case 495,955. If you actually do a simple calculation, you should be able to see that this amount is exactly the double from this value. So we should be able to conclude that the total value of the account is proportional to the annual investment amount, which is very intuitive, but it is also linear relationship. So if this goes up by, let's say, 50%, this also increases by 50%, and so on and so forth. So now let's look at the next example. So next example is actually a very similar problem. So find the value of the retirement savings account with an annual contribution of, let's say this, in this case, $1,600. And this is also made at the end of each year. And an APR of, let's say, 6.4%. So in this case, we're given the a fixed contribution amount, and we're also given the APR. The only difference it's going to make is now the number of years that's contributing. So let's say for 40 years. So from this formula, I'm going to rewrite we know that in this case, the annual contribution amount is $1,600, and the APR is also fixed at 0.064. But in this case, now we have the y equals to 40. By simply substituting everything in, we have $1,600 multiplied by 1.064 to the power of 40 minus 1, and you divide everything by the APR. So by simply doing this, you should be able to get $273,954.52. The next scenario, let's say, what about if you leave it in there for 10 more years instead of taking out after 40 years? How much would this grow? So if you decide to let the account mature a little more and wait 10 additional years after 40 years, you, with everything staying the same, the only thing that's going to make a difference is the number of years. And just by simply putting 50 for the y, now you can establish the formula as such. And by putting it into calculator, you should be able to get 530,000 and $931.66. So do you actually see the difference between these two? So you waited 40 years to take this much out. So you contributed for 40 years and your account matured up to $273,000. But if you wait 10 more years, it's only 10 more years. Compared to 40 years, it's not that long of a deal. But just by waiting 10 more years, now you actually even doubled and a little more. No, I think you exactly doubled, almost. So that's a significant amount of difference within 10 years. So what if you let it mature just a little bit more? So let's say you decide to, sorry, this was B. What if you decide to let it mature up till 54 years? So it's only 4 more years, so it wouldn't make too much difference, would it? So that would imply that y now equals to 54. And just by doing so, you should be able to get 1.064 to the power of 54 minus 1. And you can simply divide it by 0.064. And just by waiting 4 more years, now that account is $687,505 on the dot. So that was now only 4 more years compared to $50. I'm sorry, 50 years. But that just yield another excuse me, another $150,000. So that's a significant amount of difference. So we can see that the years, obviously it's proportional to the number of years contributing, but we should also see that it has an exponential relationship. So if you leave it on for, like if you leave it mature for a little longer, the longer you let it matures, it grows exponentially, as opposed to when we were talking about the amount that we're contributing, it only has a linear relationship. So by doubling the amount, you would double the value. But in this case, you didn't change anything besides the number of years of maturity. And comparing it to the 40 years, just by letting the account sit for, let's say, 10 more years, you almost double the contribution amount. And just by letting 4 more years, it actually yield another $150,000. That's a lot of difference between 4 years. So here we can see that this is an exponential relationship. Now let's look at another example that's a little bit different. So what should your monthly contribution be if your goal is to have $250,000 in your retirement savings, after 16 years. So here, assume that APR is 5%, and the monthly contribution is made at the end of each month. So from the get-go, we should know that it's a monthly contribution because it's given in the problem. Yeah, so just to explain this problem, let's say your goal is to have $250 by the time you retire. Obviously, 16 years is a very small, very short term in terms of the retirement savings account. But let's say in this scenario, for the sake of the problem, let's say you're trying to buy a $250,000 house. Let's say you want to buy a house that's worth this much and without taking any loan. You want to save up before you buy the house. So this will be more likely scenario if that's the case. So, excuse me. So since this is a monthly contribution, we need to use the monthly contribution formula. So the monthly version. So monthly contribution formula is given as such. So 1 plus R divided by 12. And you exponentiate by T minus 1, and you divide by the monthly rate. So here, we already have a goal. We already have a goal value of the retirement. So we know that in this problem that the V is already given as $250,000. To find, so here we know that the APR is given as 5%, so it's 0.05. And this would mean that R over 12 is 0.05 divided by 12. You can put this into decimal, but I prefer the fraction because this would often give you some repeating decimal and would not get you the exact number. And for the number of years of contribution is found by multiplying the 16 by 12. This is because they're 12 months and we're contributing for 16 years, and that's 192. So we actually know everything now. So on the left-hand side, the value of the account is $250,000. So we're supposing the value of the account is $250,000. For however much that you are contributing each month, we know that the monthly interest is 0.05 divided by 12. And you exponentiate it by 192, which is the number a month. minus 1, and you're dividing it by 0.05 divided by 12. So this looks a little bit little complicated, but what you need to do is you would have to calculate this. So let me say compute. Compute the terms in the bracket first, and divide each side by that value. So simply you are computing, you're plugging whatever's in the bracket into calculator, and you'll get some number, but whatever that number is, you take that number and you're simply dividing on each side. So that way, you would actually end up with M equals to 250,000 divided by the bracket amount. So I'm just gonna say the bracket amount. Obviously, you would have to do this on a calculator. Otherwise, it's going to be a very long calculation for you. But if you did this correctly, and if you put everything in as it should, you should end up with 853. So this means that if you contribute $853 a month into your savings account, after 6 years, your account will mature to $250,000. And if you were planning on purchasing a house or a supercar, whatever it is, that's how you plan forward. So before actually going 16 years further, you should be able to calculate how much you should be saving each month, just so you can get to that goal by the end of your term. So in this case, it was 16 years. So let's do one more example before I let you go today. This example is a little bit complex, so please bear with me. So this is going to be a little longer. So let's say, let's assume you expect to work for 44 years. And for the first 10 months, sorry, 10 years, you contribute $150 per month into retirement savings accounts. I'm just going to say the retirement. that pays 6% APR. So that makes sense, right? So out of the 44 years, for the first 10 years, you are now contributing $150 a month into the retirement savings account. But let's say in 10 years, you got a major promotion. So in 10 years, a major promotion, so you contribute $220. So $220, $225 per month to your retirement. For another 10 years. In 10 years, again, so in another 10 years, you received another promotion, and I'm going to omit all that language because it's the same thing. You contribute it's a, yeah, $350 a month. And in under 10 years, you contribute $500. I know this problem is a little long, but the actual problem that I'm looking at right now is a lot longer. So this is actually a little bit of a summarized version. So here's a scenario. So you start working, say when you're 20 years old, and as a first-time worker, you would not receive a ton of money. So $150 a month out of your paycheck to the retirement savings account is a very reasonable amount. But after 10 years, obviously your salary would increase. You get a major promotion. So now $150, you can actually spare more. So instead of $150,000, sorry, $150 a month, you decide to contribute the $225 a month. And I think that's a reasonable bump. And it reflects your promotion. And you've been working for 20 years by the end of this. And by the end of the 20th year, you receive another promotion. So now you can afford more to set aside. And that's 35 and 500. And let's say that's the scenario. And this is a very likely scenario because as you move up in the world, your salary would increase, you would get promotions, and you should be able to set aside a little more for your savings as you progress in the world. So I hope that was an enough explanation for this problem. So how do we go about solving this problem? So just for the sake of the problem, let's divide each contribution amount as different plans. So let's say the plan A is the first 10 years. So plan A is the first. Actually, instead of saying the first 10 years, let's say it's year 1 to 10. And plan B is from year 20, so year 11 to 20. Plan C is year 21 to 30. And lastly, plan D is from year 31 to 44. So I'm going to create a table with this plan. So let's say the first column represents the plan. So let's say plan A, B, C, and D. And the contribution is the second column. And the third is years. And last year will be month, so number of month. And lastly, the value. So this can be very confusing, so please bear with me. So for plan A, you were initially making $150 a month contribution. So the contribution here is simply going to be 150. But plan B is now 225. But instead of writing 225, I'm going to write the difference. Difference is $75. This is because if I write what I want to do is that how much I want to calculate how much the plan A yields. If I were to pay $150 a month all the way up to 44 years, and the plan B kicks in after 10 years. So with 34 years, you're now making additional $75 of contribution. And similarly, after another 10 years, you would have additional $125 that you're making on top of what you're making here. And lastly, for plan D, you're making additional 150. So I hope that made sense. So this contribution amount only reflects the difference between A and B, B and C, and C and D. So this is the increased amount. As opposed to, so if you want to, for plan B, you are actually contributing the $150 and the $75. And for plan C, you would have to add all these three numbers to get that. So if I break down the plans like this, the years would be, this is from 1 to 44. I know the plan here, I said it's 1 to 10, but for the sake of the problem, I'm going to say that you're making the $150 of contribution from 1 to 44. So the first year to 44th year. The contribution for the plan B kicks in on the 11th year, and it adds to your plan A. So this is an additional amount that you're contributing in the future. And the plan C would be 21 to 44 using the same logic. And the plan D will be 31 to 44. So the number of month. So here we know that from year 1 to 44, that is 44 years. So if you multiply the 44 years by the number of month, you should end up with 528. Similarly, this one would be 34-month period for 12 months. Sorry, 34-year period for 20 months. 12 months will be 408 months total. And for 24-year period from plan C will be $288. Sorry, 88 months. Sorry. And lastly, the rest in this case is a 14, and you're multiplying by 12 should be 168 months. So let's try to understand what this table is. So plan A, let's not think about the increase in price. Let's just think about this whole process as 4 different investments. So your first investment, you're contributing $150 for 44 years. So in other words, for 528 months. And your plan B kicks in. You're now starting a new plan of $75 from the 11th year. And that goes on for 408 months. And your plan C, which is a separate plan, kicks in the 21st year and goes on for 288 months. And lastly, your fourth plan kicks in on the 31st year of the value $150, kicks in on the 31st year for 168 months. So the value, however much that we get for each value, the total value for this whole retirement plan should simply be just adding up these 4 numbers. That's all it is. So let's do the calculations. We've done calculations several times that we know how to do them really quickly now. So let's do the plan A. So plan A savings should be you're doing $150 per month. And remember that here the APR was 6%. So since APR is 6%, R over 12 is 0.005. So here we're doing 1.005 to the power of the number of months. In this case, it was 528 months, and minus 1, and you divide by 0.005. This will get you $387,639.78. I need to make a little barrier here. The plan B. So what we calculated here is that we're assuming this plan A, you're simply making a contribution of $150 for 44 years. That's all there is to it. And plan B, when the plan B kicks in, we're simply adding additional contribution of $75, and everything else really stays the same. So the APR stays the same, and the number of months in this case was 408 months, so 408. And you divide it by 0.005 to receive 99,774.25. So this means just the plan B. So adding $75 for 34 years would yield this much. For plan C, you're now doing the $125 a month, or in this case, it's an additional $125. And with the same APR, for 288 months, and you're dividing it by the periodic interest, and that should get you another $80,139.47. So lastly, plan D, for the last 14 years, you're adding additional $150 on top of your savings. And this plan, this is 468 months minus 1, and you're dividing it by the monthly interest like this. And this calculation should yield this much. So what does this all mean? So this means that for plan A, where you're making $150 a month in contribution for 44 years, that plan alone will yield $387,000. And the plan B, when it kicks in on the 11th year, so meaning that you only contribute for 408 months, that additional $75 per month will yield $99,000. And that additional $125 for plan C would yield $80,000. And lastly, the last plan for $150 for 168 months will yield $39,000. So in order to calculate the total amount of savings, so total value of the savings is simply adding all four plans, the value of all four plans. So you're simply adding all these four numbers together, and this should actually yield you $606,899.21. So during this 44 years of saving, you actually, in 44 years, you actually yielded $606,899, and that's a substantial amount of money. So I think I'm going to end the class here for today. If you have any questions, comments, or concerns, please email me, and I hope you have a great rest of the day.